So I think we can start. So welcome to today's section. So I'll continue from where I stopped yesterday. So yesterday we were looking at SQL aggregations, and we looked at a couple of aggregations like mean, max, sum, average, etc. So we also looked at the group by function in SQL. So I'll continue from there. So yesterday we looked at grouping by single columns, but you can also do a group by multiple columns. So we'll see examples of that. So you can group by multiple columns at once in SQL, and this is often useful when you're aggregating across a number of different segments. Now, if you remember, right, when we did the order by clause, you can also order by multiple columns. But unlike the order by, for the group by, right, the order of the column names in your group by, it does not matter. No matter which column comes first, you'll still get the same results, right? So if you do group by A, B, or group by B, A, whichever comes first, there's no difference in the results. You still get the same results. And then when grouping by, you can also use the position of your column name in your select clause. So let's say I have select A, select, B, right? The first column is A, second one is B. So instead of doing group by A, B, I can say group by 1. And that one is referring to what's the first column, that's A in my select clause. So I'll do examples and it will make more sense. So let's look at some questions, right, involving grouping by multiple columns. So the first question says we should determine the number of times a particular channel was used in the web events table for each sales rep. So just give me a second. Let me try to bring in the ERD. That way we'll understand. Give me a second. Oh, so this is the ERD. So this will help us understand how we are joining our tables. So the first question says, determine the number of times a particular channel was used in the web events table for each sales rep. Your final table should have 3 columns: the name of the sales rep, the channel, and the number of occurrences. And then lastly, order your table with the highest number of occurrences first. So our column should be 3, right? The name of the sales rep, the channel, and number of occurrences. So first things first, we'll figure out the tables we'll need to get these 3 columns: sales rep name, channel, and then number of occurrences. So if you go to our ARD diagram, right, when you look here, you find out that the web events table has a channel, and this is sales rep name. So it means we need to join web events to sales rep. However, if you look, there's no direct connection between web events and sales rep. However, web events is linked to accounts table, and accounts table is linked to the sales rep table. So we can leverage this mutual connection to the accounts table. So we'll join web events to accounts and then join accounts to sales rep. And we'll now pull the columns we need, which is the sales rep name and the channel. And then we'll also count the number of occurrences and then group by. So let's go to SSMS and see how we can achieve this. So make a new query. So select, we also return the sales rep name. So I'll use S as the alias for sales rep, S dot name. And also return the channel. So from the web events table, I'll use W as the alias, W dot channel. And then count number of occurrences, right? So I'll just do a count star to count the number of occurrences, count star. And I can say as number of occurrences. So we are joining web events to sales rep, but then like we saw, right? There's no direct connection. We will join web events to accounts and then join accounts to sales rep. So I can say from the web events table, right? Join the accounts table. Join accounts table. So accounts table, right? So what we are doing, you see that web events, the alias is W for this, right? So you're saying wherever you see web event, wherever I see W in this query, right? You're referring to what web events table. So W, join accounts also, A. And how are we joining this, right? So account ID to web event account ID. So I'll say W dot account ID is equal to accounts.id from our diagram. And then we also want to join the sales rep table, right? Join sales rep table. So before I continue, let's go back to the ARD diagram. So understand how you're joining this. So if you look here one more time, right? We're joining web events to accounts, account ID to account ID. Next, we'll now join also, right, to sales rep table, account sales rep ID to sales rep ID. Right, that's what you're doing. So we've done the first part. Second part now is to join sales rep. So join sales rep on, so we can call sales rep, right, alias S, sales rep S on accounts to sales rep ID. Is equal to sales rep.id. So once we have this, right, we can then group by. So from yesterday's section, right, you see that any column that is not in our aggregation, which is count star, right, we have to put that in the group by clause. So I'll come on here and put on group by, and that will be what s.name and also w.channel. And lastly, we are asked to order by the count, right? I'll say order by. I think we can use the alias. Yeah. So once we have this, right, let's execute this and see the results. Execute. So you have the sales rep name, the channel, and the number of occurrences. So you can see here, right, we're able to group by two columns, the sales rep name and the channel. And if you want to order differently, you can see order descending So currently it's ordering from smallest to the largest, right? 1, 2, etc. When I run this now, order is now changed from the highest down to the lowest. And I said earlier, right, the order does not matter. So I can sweep. So notice, right, the results, Eli, Shusa, Benita, etc. So the top 5 guys, right, 2, 3, 4, down to 185. I can come on here and swap the order of this. So I can say channel comes first, and then name comes next. And I expect to get the same results, irrespective. So you see, right, the same results, 2, 3, 4, 185, the same names. So whatever the order you use, it still gives you the same result. And then one last thing, right? So like I said, this first column is what? 1, this is what? 2, right? So instead of using the column names, you can use 1 here. For example, you can put 1 here. Group by 1, comma, group by 2, right? And I can say order by. So this tree, right? The third column, this first, second, third. You can say order by 3, descending. I think it should work. Yeah. So let's execute this and see the results. Group by 1, 2. Let me see. This S done in the video channel. Why is this not working? So it says each group by expression must contain at least one column that is not an outer reference. That's the name. This. Let's see if this will fix it. This is external W channel. This should work now. That's the name W channel. Let me try something. So I can't think to know what the issue is, but then let's go on. But ideally, right, you can also group by the numbers here. So let's name, execute this. So these are original query, right? Group by the 2 columns, S, the name and channel. So once you do this also, you have your results. So let's go on to the next example. Next question. So 2 says, determine the number of times a particular channel was used in the web events table for each region. Your final table should have 3 columns, the region name, the channel, and the number of occurrences. Order your table with the highest number of occurrences first. So first things first, we'll figure out the tables we need, right? 3 columns, the region name, the channel, and number of occurrences. So it looks like we'll be joining the region table to the web events table. So region, channel, and occurrences. So back to our diagram, right? If you look at the diagram we have here, this is the region table. Region name, we need this region name, then channel, and then the number of occurrences. So this is a kind of complicated relationship. There's no direct connection between web events and region. However, web event is linked to accounts. An account is linked to sales rep, which is now linked to what? Region. So it means in our query, right, we'll show all these connections. Web events will join accounts, accounts will join sales rep, and this will now join region. We'll then select the columns we need, which are channel and region name, right? So let's see how we can achieve this in SSMS. So I come on to my SQL Server Studio. So I want to return the region name. Select. So I'll use arrow as the alias for region. Arrow.name, I can see as region. So it's clear. And then for web events, use w dot.channel. And then the number of occurrences. So I'll do a count star. Count number of rows, right? As number of occurrences. So once I have this now, I can then start joining my tables. So I can start with from web events, W, join accounts. So what we saw, right, web events join to accounts. A on w.account ID is equal to a.id. And next, right, accounts is now joined to sales rep. So I'll join sales rep now. Join the sales rep table. S on a.salesrep ID is equal to s.id. And lastly, I'll now join the region table, right? Join region arrow on. So sales rep is joined to table, right? On the region ID. So I can see s.region ID is equal to region ID column. So once I have this, right, I can then group by. So group by. So all the columns that are not in the application, right, will be in the group by. So these columns, aside the counts column, everything else should be in the group by. So group by these column names. And I need to put the alias in my group by. So I'll just take this off. And then you're asked to order in descending order, right, from the highest to the lowest. So I'll do order by number of occurrences in descending order. So once I have this, I can execute this. So you can see the region name, the channel, and number of occurrences, right? So for Northeast, for example, right, direct channel has the highest number of occurrences, followed by the direct channel in the Southeast, then direct in the West, etc. So that's for question 2, right? We are able to also group by multiple columns. You can group by 3, 4, etc., right? But in this case, we have just two columns that we're grouping by. So let's go on to the next concept, right? Distinct. So distinct is used in select statements, right? It always goes with the select statements, and it provides the unique rows for all columns in your select statement. So when you hear distinct, right, it's just the same thing as saying unique. You want the unique values in a set of results. So the syntax, right? Select distinct, then columns you want to return from your table, right? And one thing to note is that when you're using distinct in aggregations, right, it can slow down your queries. So most times when you're working in production databases where you have large amounts of data, you are told not to use distinct, right? Instead, you do a group by, and then you can filter on your group by to get distinct results. So something to note, distinct can slow your queries a bit, and this can be significant when you're working in very large data sets. So let's see some questions, right? We're asked to use this thing to test. Okay, before I answer this, let me just do a simple illustration of the things, right? What table should I use? Okay, let me use this web events table. Select star from web events. Select star from web events. So when I run this, I see all the results in this table. Execute. So when you look here, right, you're seeing duplicates. For example, account ID 1001 several times. You have directs several times, right? When you scroll down, you see other account IDs. So you're seeing duplicate results, right? Duplicate results. So when I say, for example, select distinct. So I put a distinct now after select distinct. So I execute this. Before I do this, let me just do this one more time. So compare the results. So this is showing you 9,073 rows, right? 9,073 rows. So it's very possible that we'll get the same result with these things because you have a date column. And this date column, right, has a time axis also. So it will be difficult to have the same account ID with an event that occurred in one channel at that particular second or minute of time, right? So it's very likely that we may not have duplicate values here. So when I put these things here, let's see the results now. These things. So when you look at the number of rows, right, still the same thing. Why? Because of the time axis, right? You have, it's down to seconds. So this is very unlikely you have duplicate values that occur the same second. But now let's just choose two columns now. So I'll choose ID and then also let's do account ID. So I choose account ID and then choose channel, right? Yeah, let's execute this now. Execute. So we still have the same number of rows, right? 9,073 rows, right? So now let's do a distinct and compare the results. So if you look at these results, right, you're having the same ID occurring several times, the same channel occurring several times, right? But when I come here and put the distinct clause, so I'm saying, give me the unique account ID and channel combinations in this table. So I do a distinct and execute this. And if you look at number of rows, right, it has reduced from 9,073. You now have what? 1,509 rows. And when you come down to the account ID and channel, right, this is 1091 Facebook, right? So in this table, I won't see any other 1091 Facebook again on the same row. I can see the same ID again, right? But I won't see it and Facebook together on the same row. I can see 1091 AdWords, 1091 banner, right? But they can occur only once. Like I said, with distinct account ID channel combinations. So that's why you have the results reduced, right? From 9,000 to 1,500 and something. Then if you go further now and say, okay, I'll just stick with one column. So select account ID, for example, or let's do channel. Select channel from web events. Execute this, right? So you still have the same number of rows, 9,073. And you're seeing duplicates, right? Direct, when you scroll down, you see other ones, right? So this direct, when you scroll down, you see other examples, organic Facebook, right? Like that. When I say distinct of this now, distinct of this, it removes all the duplicates, right? All duplicates here. Let's execute this and see the results. Execute. So you see, it's showing me just the unique channels, right? And you have just 6 channels: direct, organic, AdWords, Facebook, Twitter, banner. So what this thing does is that it returns what's the unique values, right? In a column or set of columns. That's what it does. So back to my slide, let's see the question, right? Use this thing to test if there are any accounts associated with more than one region. So I want to see if from the accounts, right, with the company, are there any accounts that are operating in more than one region? So for this, right, we'll write 2 queries. We'll write the first one, right, to look at the accounts and regions, and then we'll now do a distinct and compare the 2 results. If they are the same thing, right, then it means that we don't have accounts that have multiple regions. But if you have the first query more than the second query, then it means that you have those that might appear in 2 regions. So when we write the query, I think it will make more sense. So the first query we write, we just try to return accounts and regions from this database. So I'll say from the accounts table, right? Just to refresh our memory to see how those tables are connected, right? So here you can see the accounts table and the region, right? So account is linked to sales rep, and this sales rep is now linked to region, right? So we'll join account to sales rep, then join sales rep to region. We'll then return the region name and the account name, right? And we can also count the occurrences and see those are more than what you're looking for. So let's cancel this. And back to my slide. So let's go back to SSMS and try to test using distinct and then the normal join query. So I come on here, let's do the first condition. So I'll say, I want to get the account name. So account table.name as account. I want to get the region name also. Our region.name as region. Then I also do a count star also. Counts. So count number of occurrences. Count star as number of occurrences. So I'll start with the accounts table. From accounts table A, join the sales rep table. S on account or sales rep ID is equal to sales rep ID. And then also join the region table R on sales rep region ID equal to region.id. And then we'll group by, right? So we'll have an aggregation count. So I have to group by any column that is not in the aggregation. So we'll group by account name, comma, also group by the region name. So and also order by the occurrences. So once I have this, right, execute. So from here, right, I can tell that there are no accounts that have multiple regions since it's showing me just one. Okay, let's do descending order. Apologies. So let's descend and see if there's any multiple occurrence. So the same thing to write. All the accounts in each region, you have just one occurrence. So this account in Midwest is just one occurrence, right? And if you look at the number of rows, this was 351 rows. So I'll copy the same query and slightly edit it. So we use the select distinct clause also. We expect to have the same results. So I'll put a distinct here. So let's distinct. Name. And for this, I don't need to do any application. Just join the tables and give me the unique results. So no aggregations. And the same thing too. No need for the group by, since I'm not aggregating. No need for this also. No need for this also. So that's a simple statement, right? Return the unique names of accounts and names of regions when you join these tables together. That's what I'm trying to do. So I expect to have the same results as the first query. Then that will confirm that there are no accounts that exist in multiple regions. So I execute this also. And you can see, right, we also have the same number of rows, 351 rows. So this shows us, right, that there are no accounts with multiple that exist in multiple regions. So I did these two queries, right, just to show you two different ways of doing the same thing, and also to confirm what that the results are true, right? Both of them are giving us the same number of rows, so it means that there are no accounts that exist in multiple regions. So let's go to the next question. So this is asking us, have any sales reps worked on more than one account? Have any sales reps worked on more than one account? So this is similar to what we just did now, right? So sales reps and accounts table, they have a direct connection, right? Accounts to sales rep ID is equal to sales rep.id. So have any sales reps worked on more than one account? So let's do the first one, right? We just return the sales reps names as sales rep. And let me see. It'll be a count star, I guess, count star as number of accounts. Let's execute this and see what we have. So this is showing us that, so this is in ascending order, right? From the lowest number of accounts to the highest number of accounts. So I can see that what all the sales reps have actually worked on multiple accounts. And the lowest account, right, is 3. And when you scroll down, you see those that worked on 4 accounts, 5 accounts, 6 accounts, etc. So when I join the account table to sales rep table, right, I then count number of rows. and then group it by the sales rep name. That's what I'm doing here, right? And you can now see what for each sales rep, number of rows or number of times they appear in the table. That's the same thing as what number of accounts they've worked on. So you're seeing that what some have worked on 3, 4 accounts. And when you look at the number of rows here, right, it's showing you what 50 rows. So it means there are 50 sales reps, right? That's what it means, 50 sales reps. And let's confirm if that's true. So if I go to a new select statement, right? Select star or select distinct name from the sales rep table, for example. So I'm saying what return the unique names, right, from the sales rep table. So when I run this, execute, you also have what 50 rows. So it means that there are 50 sales reps, right? And this first result here gave us 50 rows also. So you're showing us for those 50 sales reps, the number of accounts they've all worked on. That's what it's showing you, right? And just to add something, oh yeah, you can also do a count. I think counts, distinct counts, I think. Put is after count, I think. So when you count name, get 50 rows, distinct stats. So from these, right, the first result is showing us that for each sales rep, these have worked with 3 accounts, etc. Second query is showing us the distinct number of sales reps, which is 50, right? So it means that, for example, it's very possible that when you run this query, right, maybe there are some sales reps that are not showing up here. Maybe they have 0 accounts they've worked on, right? So just to confirm your assumptions, you then come here and count the total number of sales reps, and there are 50, right? So these 50 guys are also showing up here. And you're seeing for each sales rep, you're seeing the number of accounts they've worked with, which is 3, etc., right? So it checks out. And we can say with certainty, right, that all the sales reps, they've worked with multiple accounts, 3 upwards. So that's for that question. So let's go on to the next concept, which is the having clause. So having clause, right, is used in SQL because when you're working with aggregate functions, right, the where clause cannot work with aggregate functions. So in SQL, the having clause is used to filter on aggregate functions. So before I continue, just share what I mean. Let's use the example that we have here. So when I run this query, right, it's showing us for every sales rep, right, the accounts they've worked with, 3, 4, 6, etc. What if I am now told, right, so filter this result and show only sales reps that have worked with more than 10 accounts, right? So I want to see just 11 upwards. So filter this result and show me only sales reps that have worked with more than 10 accounts. If I come on here and do a where clause, right? Let's try that and see. So I can say where counts star, right, is greater than 10, right? That's the where clause now. You're going to filter where this number of accounts, right, is more than 10. So where count star is more than 10. Let's execute this and see our result. So it tells us that what an aggregate may not appear in the where clause unless it is in a subquery in a having clause, right? But if I come on here, right, and then so the having clause, right, it comes after the group by. So instead of where I put a having, let's run it and see actually what happens. But it won't work because it's not ordered correctly. So it says what's incorrect syntax near the keyword group, right? So if I arrange this, if I take this having clause now from here, and it comes after the group by clause, it should work now. So I execute this. And you can see, right, our result is not fitting correctly. It's not showing us the sales reps that have accounts more than 11, right? This is now correctly filtering our results. So the having clause, right, is used to filter on applications. When you're doing max, sum, average, and you want to filter on the application, right, where the average of this is more than or less than, those kinds of calculations, and you use the having clause for those kinds of scenarios. That's the use of having clause. So having is a clean way to filter a query that has been aggregated, but you can also use a subquery, right? So a subquery is for a different section. So here's the syntax, right? So select column name from table. You can do your where clause, group by. Like I said, right, having comes after the group by. So when you group by, then you can now say what having, you put your condition there, and you can then order by. So let's see questions right under this. So it's asking us how many of the sales reps have more than 5 accounts they manage. So this is what we just did. But instead of 5, we did 10, right? How many sales reps have more than 5 accounts? So we just change this to 5. Just put a 5 in front of this. And execute this, right? So we have 34 rows. So it means that out of 50 sales reps, right, 34 of them have managed more than 5 accounts. So let's go on to the next one. So it's asking us how many accounts have more than 20 orders. How many accounts have more than 20 orders? So for this, I'll come back here and we'll write a new query. So you're working with 2 tables, right? How many accounts have more than 20 orders? So 2 tables, the accounts table and the orders table. And these 2 tables, they are joined via account ID. Order account ID to account ID. So for this, right, select how many accounts. So you can do a account name, a.name as account. And we can just do a simple count star. So count number of rows. So it says what has more than 20 orders, yeah, count star as number of orders. So count star means you're counting the whole rows, right? I will join the account table to orders table and then count the number of rows. Every row is an order. Then you can now group by the account name. So choose counts of the rows from, so I can start with the orders table, for example, orders O, join accounts A on O.account ID is equal to A.id. And we can do a group by the account name. And we can order by descending order. So this is now our final query, right? But let's just see what it shows us first. So I execute this, right? So this is showing us for every account, the number of orders, right, for every account. Now our question to us to filter for those that have more than 20 orders. When I scroll down, right, you see that you have those with less than 20 orders. So 19, 18, 17. Also filter on this now. I expect all those less than 20 should to be excluded from our result set. So I'll come here, right? Having comes after your group by clause. So group by name, right? We'll now say what those having counts star, right? Greater than 20, right? So we can now execute this. So currently we have 350 rows, right? 350 rows. So let's execute this and see our results. Execute. So now when I scroll down, I expect from 20 downwards to be excluded, right? And when I scroll down, that's the case, right? 21. So you have 120 rows. So 120 accounts have made more than 20 orders. So this is insightful, right? Imagine your account manager, you want to, or the sales manager, you want to see this kind of insights, doing this kind of SQL queries and filtering on your applications would help you to get that insight. So 120 accounts, right, have more than 20 orders. I think you have about 351 accounts. So out of 351 accounts, 120 have made 20 orders. And the next one says, which account has the most orders? Which account has the most orders? So from here, you can see the answer already. This guy has the most orders, 71. But to answer this right, we don't actually need, we don't need to, let me see. We don't need to filter on anything, right? You can just take this having off. You don't need to do this. We just come on here and then just choose the first row for the result, right? So accounts count by this. So we can just say select top one, right? Return just the first row in these results. Execute this, right? And here's your answer. So the Sadia National with 71 orders has made the most orders, right? So you join accounts to orders table. For each account, you count number of rows, group by the account name, and return just the first row. Once you order in the descending order, right, it means that what you're ordering from the highest number of orders to lowest, then return just the first row. And that's your answer, right? Select top one and get your results. So let's go on to the next question. So it says, which accounts spent more than 30,000 USD across all orders? Which accounts spent more than 30,000 USD across all orders? So we're still working with the same tables, but different columns now. So just to confirm we're doing right, select star from, just do a sample, select top 10 star from orders. So this is the orders table, right? We are asked which account sold more than 20,000. Let me just confirm that's the question, right? Okay, more than 30,000. So which accounts spent more than 30,000, right? So this very last column, total amount USD, that's the column that shows the amount spent on orders, right? So what we are doing is we'll join the account table to the orders table, and for each account, we'll sum up this column, right? Amount USD, sum the column up. We'll then group by the account name. So for every account, we want to see the total amount that was spent for every account. Once we have that, we'll then filter on this total amount for those that are more than 30,000, right? That's our result. So let me just start this from scratch. So I'll do select. So I want two columns, right? The account name as accounts. And then I also want the sum of the amount USD column, right? So I'll do a sum up from the orders table, the total amount USD. We're gonna call this amount spent. right? So from the others table, just the same table join we just did now. So from others table, call it O, join the accounts table, A, and they are joined by the accounts ID, right? A.id is equal to O.accounts ID. So once we have this, right, we can group by, so group by the column, right? That's not in our aggregation, that's A.name, group by the account name. So group by that. And we are asked to show the accounts where the amount spent is more than 30,000, right? So we can say having this, having the sum of amounts USD where is greater than 30,000. And we can order by same column also, order by this too. Or you can put the alias so that can work. So once we have this, I think this answers like our question. So execute. So from our result set, we can see the accounts and the amount they spent, right? But these ordered in descending order, right? If you want to see the largest account first, then you just come in here and put the descending keyword, right? So I can say DESC, descending order. When I execute this now, it's now arranged, right? So you now have what? 300,694,293,861. And when you scroll down, you now see that they are all above 30,000, right? This $30,083. So this answers our question. And you have 204 accounts, right? 204 rows. So 204 accounts out of 351 have spent more than 30,000 across all others. So next question. Which account has spent the most with us? So that's just, the answer is here already, right? This is the guy, EOG resources, 382,873. What we just do is, we don't need to do a having by clause, just take this off. And let me see, name this. So we just select top one, right? Just to the very first top one, and execute this. And this is a guy, right? DOJ resources with $382,873,000 spent. So on to the next question. This is asking us, which accounts use Facebook as a channel to contact customers more than 6 times? So we are working with two tables, right? The accounts table and also the web events table. These two tables contain the columns we need. The accounts column is in the accounts table and the channel is in the web events table. And they are both linked by the account ID, right? So we'll choose the account name and then we'll count the number of channels. And then we'll then find out those that have greater than 6. And that's our answer. So I'll come on to SSMS, right? So quickly select star from web events, right? This table we are working with, this table. So you can see it has what's the channel, right? That's Facebook. It wants to work with Facebook, so we'll filter for Facebook here also. And then the accounts table, select star from accounts. So this is the accounts name, right? So we'll join these tables together, accounts web events. We'll return the accounts name and the channel, the count of the channel. So let's execute this and see the results. So select which accounts use the channel Facebook more than 6 times? I think that's a question. Which accounts use Facebook as a channel more than 6 times? Yeah, that's the question. So select, I want account name, that's a.name as accounts. And I also want the count, so it's count of the number of rows. So you can do count channel, right? You can do count stuff. I can say count the channel column, for example. So I'll say web events table dot channel, right? This or count star should be the same thing, should give me the same result. So I can say as channel counts, for example. Before now, I've been doing count star, right? They're equivalent. So count star means what? Count number of rows. Or count channel also is the same thing, right? It's counting number of rows in the channel column. So count this as channel counts, and then I can see from the web events table, W, join accounts table, A, on A.id is equal to web events to account ID. And here I'll group by A.name. And having this column, count channel, greater than 6, right? Where the count is more than 6. And I can then order by same column also in the descending order. So once I have this, I can execute. So this looks correct, right? But we are missing something. The question says Facebook channel, right? Facebook as a channel. But currently, we're not filtering for Facebook. They're showing us all the channels. So I'll come here, right, and add a where clause that says where w.channel, right, is equal to Facebook. So that's the results, right? You have 101, 96, etc. So once I add Facebook and execute this now, it should update, right? So you see it's now fewer. So these are the accounts that use Facebook more than 6 times. There are 46 of them, right? Out of 357 accounts, 46 of them have used Facebook more than 6 times. So that's the answer to that question. So let's look at date functions in SQL. Date function in SQL. So I mentioned earlier, right, in previous sections that you have different RDBMSs. So you have SQL Server, which I'm currently working with. You have Postgres, you have MySQL, you have Oracle, etc. And all these DBMSs, they have idiosyncrasies, right? There are differences in how you write certain functions. So for example, the way you calculate months in SQL Server might be different from how you do it in Postgres, right? But it's the same concept. If you can learn and master one DBMS, then you can easily search on Google, right, for functions to do the same thing in a different DBMS. Personally, I work with Postgres, but currently I'm teaching with SQL Server, right? So you see that you can just transfer your knowledge from one DBMS to a different one. It's the same thing, just slight differences. So for date functions, there are a number of built-in SQL functions that you can use to improve your experience when working with dates. So for example, right, you have a date column, but you want to aggregate your table by year or by month or by day or by quarter. right? Your table does not have a column for quarter or for month or for year. But with date functions, you can extract those fields, right? Like a month field or a year field, and then group your data by that year field, right? So consider, for example, if you look at this table here, right? The orders table, for example, select star from orders, right? And then execute this. So if you look at this table, right, you have a column for dates, but there's no field here for a year, right? Or a quarter or a month. Or using date functions, I can extract the year from this column and group this quantity by year, for example. So I can see, for example, in 2020, what was the quantity that was sold in 2019, right? Even though the table does not show me that, but I can use functions, right, and aggregate and show those results and answer potential business questions, right, using those date functions. So that's the power of SQL date functions. So in SQL Server, right, you have some examples like date name. This returns. So date name takes two arguments, right? The field you want to return, is it a year, a month, a day, second, millisecond, etc. Name and then the date field, right? You also have date paths. So date paths, while date name returns your result, right? So if you choose month, for example, you return month as a text. Example, January as text, right? February as text. Date path will return it as what? As number. So for months, for example, date path will return 1, January, right? 2 is February, 12 December, just like that. Then you also have some other functions like get UTC dates. This returns the current date, right? And time in the UTC time zone, while get date will return the time in your current time zone, right? There are several other functions. There are a few of them. So for example, if I run the query that says select get date, for example, so I put a quote there, right? When I run this, right, it returns the current date. So I can give it a column name, right, as, just to make it cleaner, as current date. Execute this, right? I think that's a built-in function or something. Let me see, code it. Let's see, it works. Okay, that's a built-in function or something. That's why I get that error. So this showing me that what the current date is the 6th of November 2022. Current time, right, in my time zone is 9:24. Right, that's the current time in my time zone. And you check my time, right? You see that it checks out, right? Today is 9:24, my current time zone. So if I come on here and change this now from get date to get UTC date, for example, this now returns the date in the UTC time zone. That's like London, right? So London is currently 1 hour behind the time in Lagos. So you see is what, instead of 9:25, it's now what showing you 8:25. So this is the UTC time zone. This is used to when you're working on projects, right? You want to use a central time zone. So you just use UTC for your dates instead of working with your local time zone to avoid clashing with people you're collaborating with. So another example, right? So select occurred at. So that's the date column, right? From my orders table, occurred at from orders table. So that's the date column, right? And I execute this, it returns the date column. So you're seeing what's 2015. This is your date, right? Date and time, right? So if I use a function, for example, like I want to return the month So this is currently the first row is what October, right? 10th October. I want to return October as text. So I'll put the function, right? Date name, for example. Date name, right? For example. And I'll put I want to return month. So I'll put month, then put in caps. So I'll put month here, comma, and my date field, right? I can say as month, right? From this table, when I run this, right? Okay, let me return both fields, this and the original column also, or call that. So compare to all of them. So execute this. So you're seeing the month, right? This 10, that's October, 11, November, right? 12, January, just like that. You're seeing the different months, right? For each of these fields. And then if I want to return as text, sorry, as numbers, right? So I can say date parts. And I'll call that it should be correct. As months number, yeah. So date part, right, returns the month or the number, 10, 11, 12. Why date name return it as what text, right? October, November, December. Alternatively, you can also use the month function, right? Month. I also use months, right? Months and my month column, I'll call that. For example, this returns the same thing as date part, right? So you have a built-in month function, right? That's the same thing as date part. So instead of saying date part, I can just use month directly, month on your column. The same way I can also put year, so right. So I can say year and my date column, for example. I'll call that. And we extract the year right from our results as year date. So this is year, right? So this month, this year, this month number, this month. Just you have several date functions, right? Because of time, let's just go and answer some questions, right? So the first question says, find the sales in terms of total dollars for all orders in each year, ordered from greatest to least. Do you notice any trends in the yearly sales totals? So we want to find, we want to group total dollar sales, right, by year. So 2010, we made X amount of sales, 2011, just like that. That's the end goal. So let's see how we can achieve this here. So I'll just take off all this. So I'll do this first with the dates alone before we then use the year. So select or call that. And also I'll return the sum of the amount in dollars, total amount USD. the others table. So this is just one table. I need to join any other table, right? They're all in the same table. So group by the dates or that. All right. So let's see what this gives us. So notice, right? The total number of rows in this table, right? Total table is 6,912, right? 6,912 rows. So when I run this, I'm grouping by date now. Let's see what it gives us. So it gives us what? 6,908. Almost the same thing, right? And why is this? Because what? The time is granular, right? It's broken down to time, right? So if it was just dates, right? All the others that occurred in one day will be grouped together, and you have what that day and then the sum, right? But this time, so it's very, very unlikely that you have several others occurring the same second, the same minute, right? That's why you just have out of 6,912, it now returns almost the same thing, 6,908. But now instead of the actual date time, right? Let's try to use, our question says months, right? So a year. Let's try to use year now to do this. So I'll come on here right now, put year, right? As year date. And the same way also, right? You group by the same field, right? Group by year of this also. So don't forget that you also group by the same field in your select clause. So select this, group by this also. So you get accurate results. So let's execute this now. So I expect to have just the years, right? And then the total orders for those years. So from 6,908 rows, right? Execute this. You now have what? Just 5 rows. So the data spans from 2013 down to 2017. So this is currently not ordered. So it's like this, right? 2013, 16, 14, 17, 15. So based on my prior analysis, right? 2013 and 2017, their data is incomplete. They have just few months of data. So this might be biased. Other rows are in millions, right? But 2017 and 2013 are just in thousands. So you could filter them off, but then we'll just leave it for now. So when I come on here, I can order by year, for example, order by year. No, order by year. We asked if we saw any trends, right? So if I ignore 2013 and 2017, right, they're incomplete. In 2014, right, the sales from 4 million increased to 5 million, right? The next year, from 5 million increased to 12 million. So you can see, right, just by looking at the results for these 3 years, 2014, 15, 16, where you have full data, the sales are increasing year on year, right? This is easier to see because it's just few rows of data. If you have several data, then you have to plot it in a chart to actually see the trends clearly. But this is just 3 rows of data, so you can see what you want to see easily. So that's the question, right? And the answer for that question, right? Find the sales for each year and order it from greatest to least. So to actually answer the question, right, we'll order it now. Instead of year, we'll order by this some amount USD. That's the actual question, right? Order by this 2017 descending So 2016 had the most sales, followed by 2015 and 2014. So the same thing we saw previously. So let's go on to the next question. So it says, which months did Patch and Posey have the greatest sales in terms of total dollars? Are all months evenly represented by the data sets? So let's see how you can achieve this. So we just tweak this, right? So instead of year, we just put months here. Instead of year, we just put months here also. So from this, right, we can see that December, that's 12. It has the, so this should be months. Oh yeah, now it should be months. Yeah, so December has the most sales. Next is October, November, right? So typically the ending of the year, you have the most sales. That's the months at the end of the year, just like that. So the question we asked was, so this is the month, right? December with the most sales. And it says, are all months evenly represented by the data sets? So this depends on the criteria, right? If it's asking us if all the months are present, yeah, you have 12 rows. So all the rows are present. But if they're asking us if, yeah, I think that's what you're asking us, right? But if you are telling me, for example, to show the number of orders that occur in each month, for example, then we can do a count star, right? And then group by the month and show the number of orders for each month. And then see if they're all getting the same number of orders, or if there are some months that have a large order volume, while other months have less order volumes. But from this result, right, all the months are present. You have 12 months and they're all here. And if, for example, you wanted to see the month's name instead of the numbers, right? Maybe you want to see the name instead of the numbers, then you can use the date name function, right? So dates name, and here we'll put what we want to return month, right? And a comma. And we'll also group by this too, group by the month, this column. So group by this. And execute. So on to the next question. It says, which year did Patch and Posey have the greatest sales in terms of total number of orders? Are all years evenly represented by the data sets? So in this instance now, instead of the in dollars, right? We want to now count the number of orders that are made, not the amount in dollars now. So for this, I just want to do this to previous query routes. It will have year. But now instead of the sum, right, we just do a count star, count number of rows. So count star. So once you just count number of orders by year, right? The year and then number of orders as orders count. when I run this, right? So the same drill as before, right? 2016, it had the number of dollar amounts. It also has number of orders, the highest order count, 3757, followed by 2015, 2014. And you can see that 2013 and 2017, you have the least number of orders, right? And from these, right, I can easily tell that we have incomplete data for 2013 and 2017. I want to confirm this. You can just do a select month or call that as month, right? From the orders table, where year or call that, right? Is equal to 2013, for example. 2013, for example. So let's see the months that are present here. So we can just do a distinct. So only 1 month is present. That's December 2013, right? And if you look at 2017 also, you see a similar results. Only 1 month is present, 1. But if you check 2016, for example, you see that what all the months are present, right? So 2013 and 2017, they have incomplete data. So they are not well represented in our data sets. Then which months did Patch and Posey have the greatest sales in terms of total number of orders? Are all months evenly represented by the data sets? So this is just straightforward. I will come here and instead of year, we replace it with months. The exact same thing we just did. We'll put months here instead. And we'll change this to month also. We also group by the same field also, months of this. So once I have this, right, I can execute. And December has the highest number of orders, followed by November and October. So a slight difference, right? For the amount, the first was December, followed by October. But for the number of orders, the first is December, second is November. Just a slight arrangement I noticed just now. But then this is what you're asking us, right? So December is the month with the most number of orders. So let's go on to the next question. So it says, in which month of which year did Walmart spend the most on gloss paper in terms of dollars? So this is quite tricky. In which month of which year? So now you want to see both the month and year together. So if you say March, for example, in March 2016 or December 2015, that's what your results would show, right? That month and then the amount. So in which month of which year did Walmart? So you're filtering for a particular account. It means that we'll use 2 tables now, right? The account name Walmart is in the accounts table, while the orders data is in orders table. So we need to join the orders to accounts to answer this question. So we need 2 fields, the account name. Oh, we don't need the account name in the results, but we'll fit on the account name. We need the month and year, right? The month, year, and then the amount in dollars. That should be in our result set. Let's first answer that question. So let me show something, right? A new date function. So select occurred at from orders. So these are this column, right? But now I want to return just the year and month. So 2015, 10, I want to return just that, right? So for this, right, if you're familiar with Excel, you have a function called format, right? That's also present in SQL Server. So format, I want to format dates as year, month, right? So in quotes, I'll type in year, and then a hyphen. In caps, you put what? Month. So the month should be capital letters, right? That's important. So format, right? Format date as well. This format year and then month. So execute this. And you can see, right? It now returns just the year and the month. If I put the months in lower caps as the year, what happens is that it returns something 31, 34, 21, right? That's not accurate. So it has to be in caps. Note that. So this is the correct thing, right? 10, 11, 12, 1, 2, 3, just like that. So this was want to return, right? This, and also the amount in dollars. So amounts in dollars for Walmart. In which month did Walmart spend the most amount in dollars? So I'll do sum of O dot. So I'm trying two tables. So I'll put aliases. Others table O dot total amount USD. From others O. Join accounts A on A.id is equal to O.account ID. So we have to filter for where the account name is Walmart. So we can say where A.name is equal to Walmart. And then we'll go by this month and year results, right? We'll go by this. So just look at the question one more time. It says, which month of each year do you want the most on gloss? So also filter for gloss paper also. The most on gloss paper in terms of dollars, okay. So instead of this, we'll work with the gloss amount USD, not total now, gloss paper. So that's gloss amount USD, that's this. This is the amount for just gloss alone. So that will work with gloss paper, Walmart, and then we'll order by, it says we're gonna spend the most, so order by this field, amount USD, yeah. So let's see what our result shows us, execute. So let's do it in descending order, spend the most, descending order. And I'll give this a name as year months. Yeah, so from this result, right, I can see that May 2016 was the month that we made the most sales. So this for gloss. So it's good to name your columns right appropriately, so you don't get confused. For gloss amount USD. Execute this. What's the error now? Okay, the same thing here also. gross amount USD. Cool. So this is the result, right? So I can see that May 2016 had the most sales. And if you want to just show me that result, you can just come here and do a top one. Select top one, right? Execute this, and it gives you that result. So May 2016 was the month with the most amount in dollars for gloss paper. So let's look at the last concept for today. That's case statements. So if you're familiar with if-else statements, right, in Python or in Excel, right? So if-else statements, rather, if-else statements. So the same thing in SQL, that's case statements. If you write in SQL, case statements. So case statements is used for conditional expressions, right? So it goes through different conditions and returns a value when the condition you specify is met, right? Just like an if-else statement. The syntax, right, is what? Case when. So you put a condition, right? If this case is this, then return this. When is this? Return this. Else, return that, right? Just like that. So let's see examples. So the first one says, write a query to display for each order the account ID, total amount of the order, and then the level of the order, whether it's large or small, depending on if the order is 3,000 or more or less than 3,000. So to explain this, right, once we return a result with 3 columns, the account ID, the amount in dollars, right, for that account, and then we'll now create a new column, a derived column, right, that shows if the order is large or small. So if it's 3,000 or more, then we'll write what's large for that account. Else, if it's less than 3,000, we'll write small, right? And in SQL, we can achieve this with a case statement. So let's see how we can. So let me see, we need 2 tables, the account table and the orders table to achieve this account ID, order amount, and then our new column we're creating. So select on the account ID. So I'll say a.account ID. No, a.id, right? That's called a.id. Let me confirm, right? That's what the result says, account ID. The account ID. You also want to return the sum of total amount USD. And lastly, right, once we introduce a new column that says if this amount is more than 3,000, then large, else small, right? So we use the case when statements here. So I will say case when. So case when this column, I know, case when this column, some amount USD, right? So when you sum that column, case when this column is greater than or equal to 3,000, then return large. Else, we have just 2 conditions, right? If it's more than or equal to 3,000, return large. Else, right, less than 3,000, return small. That's in quotes, right, small. And the case statement, right? After writing it, then you what? You write end. That's the syntax, right? Without the end, you get errors. So else small, right? Then you end your case statement, right? You end it, end case statement. So our three columns, right? Account ID, amount in USD, and our new derived column, right? Case when the amount in dollars is more than 3,000, large, else small, then end the case statement. Once I have this now, I can then put my from clause, right? From orders table or join accounts A. I know the issue is I need to put a comma here. Join account A on O dot account ID equal to A dot ID. And here, right, since we have an aggregation summing this, we have to group by. So I'll say group by A dot ID. And we can also order by, right? Order by this. So here's our query, right? Select the account ID, sum of the amount in dollars, and then our derived column, right? When the amount in dollars is more than 3,000, large, else small, then we end it, right? Then your from statement, you group by the account ID, order by the amount in dollars. So I execute this. So we can put an alias, right? It's showing no column name here as a result. So I can say end as sales group, for example, sales group, for example, right? And let's order this in descending order. So large one should come first. So execute this. And you can see our result. This is the account ID, right? This is the amount in dollars. This is large. And when you scroll down, right, this is decreasing. So when you have those that are less than 3,000, I think that's the question, right? 3,000. So this 3,000, right? Yeah, here. So those are less than 3,000. You now have a small, right? Small, 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 just like that. So you're able to derive columns, right? Using the case statement in SQL. So it's just similar to if else in Excel. Let's look at the next question, right? This says, write a query to display the number of orders in each of three categories based on total number of items in each order. So we want to create three categories, right? At least 2,000. So when you say at least 2,000, it means 2,000 or more or greater than 2,000. Then between 1,000 and 2,000, it means 1,000, 2,000, right? Inclusive. So between that range, and then those are less than 1,000. So this total number of items, that's the total column, right? So when you look at the orders column, you have a column for total. That's like total quantity. Select star from orders. So just to make it a clean habit, right? Top 10 star, just to save time. When you're working in production environments, right? If you choose the whole table, it might take some while before it returns all the results. So you just do exploration, like the top 10. So when I run this, right, this column here, total, this contains the total quantity, right? This plus this plus this, you have total quantity for each paper type. So based on the question, right, we want to get yeah, so we want to create two columns, right? So we'll derive a column called what? At least 2000. And we'll count the number of, let me see, the number of orders. Okay, so basically we are counting the number of rows now, not the quantity, right? The number of orders. So we'll create a column, right? For this category, at least 2000, between 1000 and less than 1000. And then we'll also make a new column that contains the number of times that row appears, right? So basically, we'll have three rows, right? At least 2000 appears 10 times, for example. Between 1000 and 2000 appears 5 times, for example. Less than 1000 appears 2, just like that, right? So have 3 rows of results. That's our end goal. So let's see how we can achieve this. So our first column will be the case when statement, right? That has what? At least 2000, between 1000 and 2000, and then less than 1000. So select case when so select case when count star, right? Count number of rows. So number of times when the just confirm, I think the right thing. I think for this, I'm summing the total quantity and then grouping that and then case when sum of the orders column. Yeah, I think that's what you're doing, right? So this total amount will then group by this where it's more than 2000, etc. Let me just look at it one more time. Sure, I'm doing the right thing. Because it's the number of orders in 3 categories, number of items in each order. Right to display the number of orders in each of 3 categories. Just do simple explorations, confirm something. Select orders, select total order from orders. Okay. So it says between, the first one is at least 2000. That's greater than 2000. Greater or equal to 2000. Then we can just say in quotes at least 2000. and say when $10,000 and $2,000, then return between 1,000 and 2,000, and then any other scenario, right, should be less than 1,000, else return less than 1,000. So return these and what else? Let me see from that question. The number of orders in each of these categories. Okay. So also do a count star. Number of rows. So group by this, right, from the orders table. Let's see if this works. Okay. Yeah, so end as I'll just call this orders grouping. Oh, I need to take out this. Okay, cool. So let me order this now. Order by count star. Descending. So I execute this. Okay, cool. So let me explain what we're doing. So the question is quite confusing, but let's figure it out. So you're asked to write a query, right, that breaks down the quantity of orders into three categories. So the first category, right, for the total quantity, where is what at least 2,000, that's 2,000 or more. Second category now is where is between 1,000 and 2,000, right? The last one now is what where is less than 1,000. And then we'll count the number of rows in our table that meets this criteria, right? So the rows where the order quantity is more than 2,000, how many are they? The rows where the order quantity is between 1,000 and 2,000, how many are they? And those that are less than 1,000, how many are they, right? So from here, right, we first created the groups, the three groups, right? So here you're saying, look at all the rows, right? Anywhere you see total column more than 2,000, then you should have this group called what? At least 2,000. Anywhere you see total column between 1,000 and 2,000, then call it what? Between 1,000 and 2,000. And lastly, right, the rest that are less than 1,000, call them what? Less than 1,000 group. Once you have this now, then count all the number of rows in our table, right? That's 6,912. And then group it now by what? This is our new group we created, right? I want to get the results. So I think the issue we're having was that this group by, you put the exact same query, right? This same case when statement, you put everything like this until the end. You put that what's in this group by clause. Remember what we said, right? Anything that is not in your application, right? You put that in your group by clause. So we'll put that whole thing here and you order by the count, right? And we can see that what's most of the orders, they are less than 1,000 quantity, followed by those that are between 1 and 2,000, 511, and those that are at least 1,000, at least those that are more than 2,000, right? There are 70 of them. So that's the answer to this question. So if it's not clear, you can ask a question in the chat, right? So on to the next one. I think we'll have two more questions, then we'll round up. The next one says, we would like to understand three different branches of customers based on the amount associated with their purchases. That's the amount in dollars, right? The top branch, right, include those with lifetime value. So those that total sales is more than 200,000. Second one is between 200,000 and 100,000. And lastly, under 100,000. So this is similar to what we just did now, right? So we have results that contains the account name, total sales, and then their level. So let's just do this quickly. So select, if you contain the account name, so aid or name, and then contain the amount in dollars, I think, and then the new group. Yeah, that's not level, yeah, that's correct. Okay, before I let me answer your question, Kenneth, before I leave here. I use the alias of the case when, so I come here and put in orders group here. I think I tried this previously. I think this works for me in Postgres, I think. But when I tried here, for some reason it's not working. So group by orders group is giving me an error, right? So you can see the thing that is not accurate. Order group is not accurate. So
order group instead of orders group.
Okay, orders group, yes. Yeah. Yeah, it's the same thing actually. Orders group.
Okay.
So I think you just put the same thing there, right? And this time it should work. Yeah. So let me take all this stuff off and then answer a new question. So it says return the account name or ID. Account name, yeah. Account name, total sales and level. So account name, I'll just do aid or name as account. And then I also want the sum of amounts in dollars, sum O dot total amount USD. As dollar amounts. And then lastly, right, our case when statement, right? So we'll say case when this sum, case when this sum. So one thing, right, let me just confirm the groups again. I think it's 200, more than 200,000, between 200 and 100 and less than 100, okay? Is greater than 200,000, right? Then we can say, case when this is, then we can see what are the groups again. We actually use okay, top spenders, medium spenders, low spenders. So I can say call this group high spenders, for example, high spenders, for example. And I can say when this is right, when this is between 100,000 and 200,000. And we can call these guys medium spenders. Then medium spenders. And then the rest, right, should be less than 100,000 and say else. You can say least spenders or low spenders, anyone that suits you best. And then we end this, right? So I can say end as, so we'll call these customer group, right? Yeah, cool. So once I have this, what's the next thing now? Our tables you're choosing from. So I can say from orders table O join accounts table A on A.id equal to O.account ID. So once I have this, we'll then do a group by. It might give me an error, I think. Could this work actually? So let's do a descending. And let's confirm if our results check out our analogy. So those that are more than 200,000, right? We call them high spenders. And this, they look accurate, right? So when I scroll down to those that are less than 100,000, right? So these are all these spenders. Those that are above, so between 100,000 to 200,000, those are medium spenders, right? And that checks out. From 200,000 upwards, they are now high spenders up to 200,000. So it works correctly. So that's the logic for that. Then let's do the last question and we'll round up for today. So this one says the top performing sales reps, which are sales reps that have made more than 200 orders. So a table with a sales rep name, total number of orders, and a column with top or not. So this is straightforward, right? If you have more than 200 orders, you're a top sales rep. If you have less than 200, less or equal to 200, then you're a low performing sales rep. So let's do this quickly. So I'll come on here. So based on the ERD, right, from my head, I think sales rep and others. That's what I need. So sales rep is not connected directly to others. However, sales rep is linked to accounts. Others also is linked to accounts. So we'll join others to accounts and then account to sales rep and then choose our columns. So I'll do a select statement, select, so I want the sales rep name, s.name as sales rep. And I also want the number of orders. That's simply counting number of rows, right? Count star as order counts. And I can then say what's case when this count star is more than 200. But when it is more than 200, right? When you count number of orders, it's more than 200, then I can say what's top seller, top performing. I know about any name that suits you, like top performing or top seller, or there's some, let me do top seller. I think that makes sense, top seller. So we have just two conditions, right? Else, if you are less than 200, then yeah. So top seller in quotes, right? In quotes, single quotes. Else, I'll call this low seller. And then, so I need to move this inside this place. And I end this, right? End as sales rep grouping or sales rep group. So once I have this, right, you can then put our tables from orders table, orders O, join accounts. Wait, come right here. I always forget this. Come right here. Join accounts A on older account ID equal to A.id. And then join the sales rep table S on A.sales rep ID is equal to S.id. And then let's see, we have a count star, right? So we need to group by. So I'll do a group by the sales rep name, S.name. And then we'll order by the counts in descending order. Order by count star in descending order. So from what I've seen, right, order by, it works with the alias also. So I could put the alias, but when I do group by, it does not work. I don't know why. So order by order counts, right? That works when you do order by like this. So let me execute it and see if it gives us correct results. Yes, I think this checks out, right? More than 200 top seller. Then for less than 200, right, you have what? Low seller. So this checks out, right? This makes sense. And we'll have 50 sales reps, right? 50 of them. Yeah, that checks out. So this for the case function, right? So this brings us to the end of aggregations in SQL. So any questions on this before we wrap up for today? Okay, time is fast spent, right? Someone saying something?
Yeah, the data set, thank you for the section, Abina. The data set, is it going to be available in case we want to go through everything?
Yeah. So before now, right, we've had other sections. For SQL, right, like we've gone through creating a database. So the data set was provided in that section. So what I would do is I would share the SQL playlists on the group again, right? The very first lesson, you'll see the links or the data sets there that we are using for these questions. So if you go to the first video, I think you see how to create a database yourself and put data there and then run the query.
Okay.
Yeah. So if there are no questions, right, thank you all for your time and have a great night's rest and an amazing week ahead. I'll catch you guys next week. Good night, everyone.
Yeah, thank you.
Yeah, thank you.
Yeah.
Good night,
Yeah, you're welcome.
everyone.
Bye. Good night.